Welcome back. So I'm going to go over recursion, and I know we've mentioned it in one of our chats, but now we're going to discuss it in depth. And the whole idea of recursion is quite simple. So when a method can call itself, we call this method recursive. Meaning it can recall. It's something that calls itself and go over and over again. And something might just click in your brain immediately. Isn't that supposed to be a loop? Exactly. So when a method calls itself, then it's similar to a loop. And just like every other loop, a loop needs to get stopped. So a method that calls itself, if it doesn't get stopped, it's going to result in a Stack Overflow error, meaning that whatever you're trying to do in that loop or that method that calls itself goes on forever and it cannot stop. Then the computer memory gets filled up. So I'm going to show you very basic examples of recursion. And I'm going to show you some programs that look like a loop at first, and then we can change how you can change those programs into a method that's a recursive method and eliminate the loop. Again, don't forget, recursion means that you have a method that can call itself over and over again. It also has to be able to stop. When it's stopping, we call this point the bottom of recursion. So anytime it calls itself, it starts to move closer to the bottom where it's going to stop. So recursion is best seen in action. So let's see an example of how recursion looks like. So these are two problems that are very simple problems, and I'm going to show you how you can solve this problem using recursion and how you can solve the other problem using recursion. So these problems, you would agree with me that it's easy to, let's say, display NAs. Let's make this generalized, NAs. All right. First one, display n to 1. That's like you're displaying 1 to n, but in reverse order. To do that, you can use the for loop that starts from n and goes to 1. Again, loops can be replaced using recursion sometimes, most times. And then we're going to see how we can do that. And recursion, again, is the method that calls itself. So, piece of cake. The second one also, we're going to display n number of a's. So if the user says maybe 10 or 20, then we can get all the a's out. So I'm going to pop up my Visual Studio, and I have it here. So display 1 to n, if it's 1 to n, let me just turn the name of this method to n to 1. All right, means I'm going to read an integer number n, I'm going to start from n, and I'm going to be going to 1, I'm going to go -1, and then that would happen. All right, so, and if I run this, so let me just call this method just to, and I give it 10 and I run it. Give it a second. You can see it's done. That is n to 1, all right, using a normal loop. So we want to see how to do the same job with a recursive program or a recursive method. All right, so I'm going to collapse this and I'm going to go to a recursive method that I defined here. I call it display n to 1 recall. All right, so now let's look at how the logic works. If I know what my n is, maybe it's 10. All right, when it comes into this method, what happens? It's going to check if I'm at 1, and if I'm not yet at 1, then it's going to display whatever n is and recall. And call that method again, then subtract 1 from it. So is n1, am I at the last destination? No. So if n is 1, that means if I'm at the last destination, display that 1. However, if I'm still on maybe 10, if n is 10, then display 10 and call this method again -1. So it's going to be 9 here. When this method is called, 9 is going to come here. It's going to check, am I yet at 1? It's no, so it's not going to execute this guy. It's going to come here, and 9 will get displayed, and it's going to call this method again. This time, 9 minus 1 will give us 8. So it's going to keep doing this until it gets to, say, 2, for example. Then if 2 comes in here, it's going to check, is it equal to 1? It's a no. This is the stopping criteria that I spoke to you about. So all recursive method must have an execution part of the code where the method does not call itself, and it must also have a part of the code where the method calls itself, but get closer to when it's going to stop. Because if I don't get closer by saying n minus 1, then it will run forever. It will call itself every time, and every time I keep going on forever. And we don't want that to happen. So n is going to reduce it to 2, and when it comes here, it's 2 equal to 1, it's no. It's going to display that 2 anyway, and come here. If it's not equal to 1, so it's not going to execute this part. It's going to come here, display the 2 anyway, and recall now it's 1. All right. When it comes back here, is n equal to 1? The answer is yes. So it displays 1, and there is no other recurring that is happening. There is no line of code in this part of the condition that allows the code to go over again. Hence, it's going to stop because now whatever needs to be displayed is being displayed. I want to remind you sometimes this method is void, meaning it returns something, nothing technically. But however, our output is displayed with a right line. Sometimes you need to make this method return something. We're going to see examples. And in such cases, you're going to put a return type, and the return statement will be here, somewhere here. You're going to see an example of that. So let's run this program and see. And if you run it, you can see exactly the same output as we have in the previous example when we just used a simple loop. So simple loop, let's look at the next exercise, display NAs. So what I'm going to do, I'm just going to make a slight modification to that one. So I'm going to come to this method, not this guy. Okay, let's start with this method. So with this method, if I want to display 10 A's, okay, let me call it display A's, and n is 10, I can go from 1 to 10. 1, and this is going to be less than or equal to 10, and I have to increment because I'm going forward, plus plus, and I display an A. All right, that's it. That's the question. So says display n A's, n number of A's, and that's it. So this solves the problem. So I'm going to try and call this method to show you the output. I can just use this to check where my void main is. So I go to the main, it's here, and I change this method. So I give it 10, and I'm expecting 10 A's. I run the method, and I have my 10 A's there. Right? If I want to now make that method recursive, I can go to my recursive method that I have before that is displaying n to 1. Let me just copy this method and replace it so I can show you how much it will change. So display, I can call it n A's with recall. Okay, you give it n. So what do we do? Now let's think through this. How do we display 10 A's with recursion? First, we need something that calls itself again for another A, all right, which is this part. And we need to know when to stop, all right? So we can stop when we get to 1, okay? Because when we get n here, it's probably going to be a 10. I want to be displaying A until we get to 1, all right? So when we get to 1 and we need to stop, we still display the last A. So what's going to go here will be the A. However, for every other number between 10 and 1, we need two things. We need to be getting closer to 1, which is calling this method again. So we'll call this method from inside itself and be reducing it by 1. And each time we call it and we reduce it, then we display the A. All right. So again, this is a recursive version of the example I just showed you. I'm going to make a tweak to show you an example where the method has to return something. But in this case, the method has not to return anything, just display something and n times. So let's run this one. Okay, I'm not sure I've called the method. Let's see. Let me just be sure that I've called the method in the main. I go to the main method. Yeah, I have not called it, so I'm calling the recall one, which is the new method that I created. Wait for it. Yes, so it's up. And as you can see, 10 A's are displayed. Perfect. All right. So for these two examples, what if I want to turn this method into a string? So I want the method to return a string of A's, okay? And I want to still use recursion. So it's underlining the method now because it cannot see any return statement. So I'm going to have to return on all of the paths. So I'm returning here. So if n is 1, it should return just A. So I'll say return A. Return A, all right? However, if n is still like 10, 9, 8, and I want to be reducing, getting closer, I have to return another call to the method itself, all right? Which is now A and plus that, all right? Then I remove my right statement here. All right, so let's look at this example. Let me re-explain it. These are very tricky topics. So you call this method with an n, you want it to display 10 A's. It checks if the n is 1, then it just display 1 A for you. It returns the A back to where you call it from. That's fine. However, if it's not that, then it keeps reducing this n every time by generating an A and concatenating that A with the next call it's going to make. So the next call is going to make, this part is called the recursive part of your function call, and this part is called the bottom of recursion because this is where the recursive algorithm must stop. All right. So display n, A's, and recur. Let me just make it B so that you can see the output is different this time. And in this case, I want you to also observe that because we are concatenating, so the B's are going to be in a string and not like different lines. Okay. So let me see where we've called that method from. Go to main. As you can see here, we call the method without displaying anything because inside the method at the time, there was a right line there. But right now, there's no right line in the method. So one thing you might want to do is to put a right line here. Console.WriteLine. So W is cap. L is cap. All right, console.WriteLine. Then I call the method. And when 10 gets into this method, what happens? Let's trace it again. Go to definition. When 10 gets in here, it checks if 10 is 1. It's not true. It's not true. It's gonna come here and keep generating B's, concatenating it with another call of that same method. Keeps looping, reducing n every time until we get 10 B's. All right. So I'm gonna run this now. As you can see, it works. All right. So let me add one quick problem to that one, and we can then look at how this thing actually works. So if I ask you to generate n strings of the sequence, okay, and the sequence looks like this: X, and then it has A, right? So let me that be the first sequence, right? Let's have another sequence. So this one will be for if n is 1, 2, 3, 4, 5, 6. If n is 6, okay, that should be displayed. If another sequence, A, B, all right, A, B, A, B, and let's say Y. All right, for X equals, for N equals, let's see, 1, 2, 3, 4. Let's make that 4. So the question is, how do you write programs and recursive function that can do this? All right. So it should go, when you look at the pattern, something should strike you. The A's should recur, however, it should start with an X. All right. It should start with an X. Okay. So here, AB could recur on this side. However, it should end with a Y. All right. So these are practice. You can try to think of a recursive method of doing that. All right. just because recursion can be quite tricky. On the practice PDF, I have more discussions and examples there for you. So for this one, I'm going to leave them to you to practice. If you struggle, ask any of the tutors, but they will show you it's quite relatively simple to pull off something very simple like this. All right, so I'll come back here and I'll show you. For the Fibonacci method, you are used to that. Here I have a recursive definition of that method. You know, Fibonacci sequence goes like this: 1, 1, 2, 3, and every subsequent number is an addition of the two preceding numbers. And when you look at that, there's one thing we call concurrent, recurrent dependability in recursion. What does that mean? It means that you need to find the recursive formula. What is going to be recurring? In our example, this is what is going to be recurring. So that's the formula right there. In terms of Fibonacci, these and these are the recurring part of Fibonacci. So we know that if f is 1, recursive Fibonacci is 1. When f is 2, Fibonacci is 1. However, for any other Fibonacci after that, it is the Fibonacci of the first and the second terms that generate that. So for any I you pick, let's say you pick I5, F5, I equals 5, then F of that, F of 5, you're going to have to look for F of 4 and F of 3, all right, to get the next fib. And here is the program, the recursive method that does that. So your fib, again, in this case, we just used long. Long is like integer, but like with a larger buffer size. We check if n is less than or equal to 2, then it should return the value of 1. However, if that is not the case, then this is the recursive call. This is the bottom of recursion. This is the recursive call that takes the fib of n minus 1 and the fib of n minus 2 and calculates it again, adds them together. And this does the Fibonacci job. So I want you to try to run this code. And any questions, you can follow up with me maybe next week or with your tutors before the lab for the week. All right. So a few things you might want to know about recursion. Is it always the best way? Should I use a loop or should I use recursion? It's not always the best way to use recursion. And here's an example. A Fibonacci problem is a specific example where recursion might not be perfect. Because you know if you that when you're trying to calculate fib of 7, because your recursive call calculates fib of 6 and fib of 5, and fib of 6 call calculates the fib of 5 and fib of 4, so you realize that some calculations become redundant, meaning they happen more times. Like the fib of 2, for example, then happens too many times. Calculate fib of 2 here, fib of 2 here, fib of 2. However, if you use the simple Fibonacci algorithm, which is first equals 1, second equals 1, fib equals first plus second, you step into the loop, first equals second, second equals fib, if you remember the algorithm. If you use that one, you wouldn't have to recompute this thing every time. So certain instances are there, like this one, where recursion may not be the most optimal, we call it inefficient, way of doing it. Then there are some terms we use like direct versus indirect recursion. When a method calls itself, we call it direct recursion. However, if there are 3 methods and one calls the second calls the third, and the third calls the first one back, then that is called indirect recursion. So just concepts you can read about. Bottom of recursion, I've shown you examples of bottom of recursion and I've explained it to you. And some problems you can also solve with recursion is the factorial problem. So with the factorial problem, the recurrent dependability that I told you have to find out, which is going to be the recursive part of your program, is this one. So you know the factorial of a number is the same thing, let's say factorial of 5. It's the same thing as 5 times factorial of 4. All right. So the moment you realize the factorial of a number is the same thing as that number times factorial of the number minus 1, then you can use that as a recurrent dependability in your recursive call. And you can call the same method on this part, all right, while you multiply it by the current n at the time. And again, the code is right here, so you can have a look. Bottom of recursion again is here when n is equal to 0. Of course, we know factorial of 0 is 1. However, if that is not the case, we return that number multiplied by the factorial of the number minus 1. So it's going to call itself again and again and again and again until it calculates the multiple. And then when it finally gets to 1, it multiplies by 1 and the value is returned. I want you to type all these methods, check it out. They all work and it's all Fine. So, okay, yeah, so here's the practice. So please exercise with that. And for a second, I'll just show you like 2 more recursive methods I have here. I think I have, let's see, display, recall. I think pretty much we've seen all the recursive methods that are here. Let me see. Oh, okay, look at this method. So this method recurs, however, displays a C in the end, and it displays AB many times in front, and make sure that the last thing is a C. Again, trace this method and then see how that is done. In the next week, we're going to go into object orientation fully, and we'll discuss some newer topics. However, this week's lab is going to be based on recursion and some methods aspect of recursion. I'll see you on the other side. Boom.